Hello Matrix and welcome again. Today we are doing sigma notation. So what is sigma notation? Well, this symbol here means that you need to find the sum of all the terms where you substitute x for 1 and you go all the way up to 10. So you would then substitute 2 into x for the second number. So we're doing sequences in series. So what this basically means is you're going to get a sequence and then you need to sum that sequence. So let's just take it step by step. So the first thing is the first term, t1, is going to be 2, and then we're going to substitute in x is 1, and we're going to get an answer. And then we take this for t2, and we'll sub in 2. And t3, and after this, once we've substituted in all of the terms, we're not going to go all the way up to 10. That takes too long, so we're going to look for a pattern. So t1 we substitute in 1 for x, t2 we substitute in 2 for x, and t3 we substitute in 3 for x. So we go all the way up to 10. And let's look at what we get. So the first one we get is 3, then we get 5, and then we get 7. And if we see here, we have a common difference of 2. 5 minus 3 is 2, 7 minus 5 is 2. So we get a common difference. We know we've got an arithmetic sequence. So anytime you see a 3x plus 2 or a 5x plus 2 or something in front of an x, you know it's an arithmetic sequence by going up by difference of 5. Well, we know how to sum an arithmetic sequence. We just get the sum formula for an arithmetic sequence. So I'm going to do that in blue. So from the video on summing an arithmetic sequence that you've done earlier in this section, n over 2, 2a plus n minus 1 times the difference. Okay, and all we do is substitute in our values. So S10, because we're doing up to 10. Now, if this started at 3 and went to 10, just remember that the number of terms is not going to be 10. It's going to be, so here the number of terms is 10 because it goes from 1 to 10. If it was from 3 to 10, it would be 8 terms. 3, 4, 5, 6, 7, 8, 9, 10. 8 terms. So it's not 10 minus 1, because 10 minus 1 gives you 9 terms. You've got to add the 1. If you think about when you are building, say you wanted to build a fence, a 2-meter long fence, and there was 10 meters between each pole, you would need 3 poles because you need that outside pole. So 2 meters, but 3 poles. So it's the same concept there, just in case. So from 3 to 10 would be 8 terms. 10 to 1 is 10 terms. So we substitute in 10 over 2, and then our first number was 3, plus, and then our n is 10, and we multiply that by the difference, which is 2. And we can just put that in our calculator. Now, for those of you who have silver calculators, you obviously can't just use them and put in the answer. You're not going to get the marks. But you can actually use your silver calculator to check, which is why it's sort of a little bit strange that the department allows these calculators, because it gives a little bit of an advantage for the people who have them over these calculators, the traditional one. But you shouldn't blame your tools. If you understand the work, you don't need the silver calculator, but it does help you in cases like this where you want to check. So let's look how we would do that. So what we would do, we can see the sigma notation button above the log button. So we would say shift, and we could put sigma in here. And we see that our rule is 2x, so 2, and then we see the x here, the red button. Oop, 2 alpha x plus 1 there we go, and then we put in the first x, which is 1, and it goes all the way up to 10, and we just say equals, and we get 120. So rather than put this whole thing in, although it's probably about the same speed, but that will give you an answer for 120. So you would then put in equals 120. And so that would be your answer. So what they could also do is they could put another type of governing rule in here. So instead of 2x plus 1, they could give you something which perhaps they could give you, say, a half. So they could give you something like a half. I'll just write it in green at the bottom. So the rule could be a half to the x, something like that. And they could say, but here what they could do is they could start at 1 and infinity. Now here all you would do was you would do the same method. You would say t1 is equal to a half to the 1 is a half. t2, a half to the 2 is a quarter. And t3 would be a half to the 3, which is an eighth. And what you would find here is you would get a ratio. So you would know that you are dealing with a common ratio. So you're dealing with a geometric sequence. And so you would use the sum of a geometric sequence to infinity, which is a. I'm going to do it over here, a over 1 minus r. Your a is your first term is a half. And your common ratio is a half. Because a quarter over a half is a half. And so you would say 1 minus a half, and you get a half over a half, which is equal to 1. And so your answer for this would equal 1. So whatever they put as that rule, as that 2x plus 1 in place of that, just do the same steps. Get t1, t2, and t3 and see if you can see a pattern. And then just sum those terms. So hopefully that helped. If it did, please find the subscription button and subscribe if you haven't already, and like and share, please. And yeah, all that good stuff. And I will see you in the next section where we'll be doing functions. So look forward to seeing you then.